Hello, and in this video we're going to do rates of change and behaviors of graphs with this rates of change. So in the rates of change area, we're going to look at rates of change. What is the definition? How to find an average rate of change from a chart or a graph. How to calculate it using function notation. That's what we're going to do with rates of change. So this is our rates of change section. Then we're going to do behaviors of graphs, which is increasing and decreasing parts of graphs, max and minimums, inflection points, and concavity. So those are the sections we're going to cover in this video. So let's start off with rates of change. So a rate of change is a ratio of the output quantity with respect to the input quantity. We want to use labels in this ratio, so we're going to write them as a rate. Okay, here's an example of a chart, and this is the population in Eugene for these qualifying years. We're going to look at what is the average rate of change or what's the rate of change between the years. Okay, rate of change between years 2010 and 1970. What's our rate of change between those years? So to do that, we want to look at what the output values are. So here's our chart. Here's our output values for 2010 and 1970. So we would then put those as a difference. So we're going to do how much did it change. So it'd be 156,527 minus 79,028, and we're going to write that as a ratio between the years. So that would be 40 years where that occurs. So we just have to compute, because from 1970 to 2010 is 40 years. So we take the subtraction of the total population. We get 77,499 over 40 years. So this is people per year. So we would divide to get our average. So this is our rate. This is how many people, but our average rate of change here, or the rate of change is 1,937.4. We probably just leave it as that, people per year. And we would have this symbol, we would have those quantities here, people in years, as a rate. Okay, so that is the rate. You can also say that you got 77,499 people in 40 years. That's a rate also. This is the average rate when we actually divide. So if we're going to do an average rate on a graph, we're going to take the y values of the graph and subtract them, and the x values in the graph, subtract them, then divide to find the average rate of change in a graph. So in a chart, we're looking at the same thing here. Rate of change happens by the same method as average rate of change. So what we would do here, let's say we're going to go from x equals -2 to x equals 1, and we're going to look at the average rate of change there. And the average rate of change looks very similar to slope. the slope definition we had in a previous class. It looks very close to, it's the same definition. Average rate of a change of a graph is the slope between those points here. So what we would do is we'd look at this graph. At -2, we're down here at -8. So our point is -2, -8. And our other point is 1, -2. And we would then use the equation to figure out the average rate of change. So here our average rate of change is -2 for the y value minus -8 over 1 minus -2. So we're going to have this changing to positive here and this changing to positive. So we're going to get 6 over 3, which is the average rate of 2. So we're going to have an average rate of change of 2 over 1 in this graph. So if we went from this point here on the graph to this point here on the graph, our average rate of change would be 2 over 1. So we go 2 over 1, 2 over 1, 2 over 1. That's how we get there, 2 over 1. So that's what it looks like. It is the slope. Okay. Now if we have average rate of change of a function, we're going to change your slope equation to function notation. So these f of b and f of a, they represent y2 and y1, where this is x1 and x2 in the interval. Okay, so the interval gives us the x values. This is the y values here. We're going to do a couple examples of this. Sometimes they'll give you values here, and sometimes they'll give you rates of change here, how much we're going to change by. In this example, we went up by h instead of going up by 6 here. If we went from -2 to 4, we went up 6 here. Okay, here we're going up h. From 2 to 2 plus h means we increased by h. Okay, so average rate of change, same thing here. We're going to, what I would do is plug in h of 4 and h of -2 and find their values. So if I put 4 in here, 4 squared is 16. Then we're going to multiply by 2, which would be 32. And so then we would do 5 minus 32 and 5 minus 32. So it's 5 minus 32, and that would equal -27. Okay. All right, so that's what h sub 4 is. That would be representing f of b for me. Now h of -2, -2 squared is 4. 4 times 2 is 8. So 5 minus 8 for this one. So that's going to be -3. Okay, so my formula here, f of b minus f of a over b minus a, we're going to go a and b here. This is a and b. So b is 4, so this is f of b right here. So we put in -27 for this value, minus f of a, which is this value, so that's minus -3. And then on the bottom we'd go b4 minus -2. Again, we're going to change signs here. These become positive. So we're going to get -27 minus 3, which is -24. And then the bottom number is 6. So the average rate of change here is going to be -4 for this value. So that means in this function between these 2 points on the graph, we have a slope of -4 if it was going straight line for the points. This is not a straight line graph, so it's just an average of that. Okay, last problem here. In this part of average rates and rates of change, we're going to plug in something else here. We're going to plug in a value that's not a constant. So we're going to do f of 2 plus h minus f of 2 all over 2 plus h minus 2. So this is going to be our equation. This represents f of b. This represents f of a, where this is a and b. And this is b here. And this is a. And we're using the same equation as given before, but we're going to evaluate these. We have to figure out what that is. So over here on the side, I have to figure out what f of 2 plus h is. So I need to plug in. It's not as easy as the one previous because it has a variable in it. It has an h in it. So I can't just say plug it in and then work it out with a calculator. So in this case, we have to do FOIL on this because it's 2 plus h times 2 plus h. So this is really 3 times 2 plus h times 2 plus h minus 2. So we're going to do I'm going to multiply here first. Multiplication is commutative, so I'm going to do the actual FOIL part first and then multiply by 3. So to do that, I'm going to get 3 times something minus 2. So I got 2 times 2, which is 4. Outside is 2h, inside is 2h, so that's going to give me 4h. And the last 2 is h squared. Okay, so if I multiply that out, I'm going to get 12 plus 12h plus 3h squared minus 2. Okay, so that's the value that goes for this part right here. Okay, so that's that value. Now, if I just evaluate f of 2, that's going to be easier. So f of 2 is easier. We just plug 2 in there. 3 times 2 squared minus 2. That's going to be 4 times 3, which is 12, minus 2 is 10. So f of 2 is 10. 2 is 10. All right, and then this part is already ready to be worked out as well. So we're going to get 12 plus 12h plus 3h squared minus 2 minus 10, because that's what this is. So this whole part is this part. Then we're going to do minus 10 over our part that we already have here, 2 plus h minus 2. Okay, and then we're going to simplify. So to do that, we're going to combine all our like terms. So we have some constants we can combine. 12, we have a constant 12 here, and minus 2, minus 10. In that case, they all drop out. 12 minus 2 is 10. 10 minus 10 is 0. So we're going to have 12h plus 3h squared left on the top. And the bottom, 2 minus 2 is going to drop out. We're going to leave h on the bottom. Now we can factor out an h on the top to reduce even more. Or we can think of dividing that h out so that we can reduce the h's from the numerator and denominator. So our answer here is 12 plus 3h. So our rate of change, their average rate of change is 12 plus 3 times the h value. We don't know what the h value is here. It could be any value added onto 2 or subtracted. But we now know the average rate of change based upon that h value. All right, so that is rates of change. This section right here, where we have this kind of thing, it's called a difference quotient because there's a difference involved in the numerator and the denominator. It's a quotient because we're dividing afterwards. So it's called a difference quotient. Okay. All right. The next part of this assignment is a little bit different. So we're moving on to increasing and decreasing local max, local minimum, inflection points, and concavity. So we're moving off from rates of change to those topics. So an increasing function, as you move right, your output increases. If you move right, you're increasing for x, and the output decreases, that's a decreasing function. And you have local maximums and minimums when those increasing and decreasing values change. If we're increasing, then we're decreasing, then it's going to change. So like on this graph, these values are increasing because we're always going to the right on the function, so we're going this way. If we look at this piece of the graph, that piece of the graph is going up as we move to the right on the graph. As we follow the graph to the right, it's moving up. As we follow this to the right, it's going down here till right there, and then it's going back up. So there's two places where it increases and two places where it decreases, or one place where it decreases. Okay, and this point right here is called a maximum, or a maximum point, because it's increasing then decreasing. And this is a minimum point because we're decreasing then we're increasing afterwards. So this is the maximum point. We're increasing here, we're decreasing here, and we're minimum point, and then we're increasing again. Now they're going to ask, or I'm going to ask for intervals where this happens. So I'm going to use interval notation here. So we're assuming this function goes on forever. So I'm going to be increasing, and these are x values that we're going to look for. So we're going to look for the cutoff right here for the first interval. So it's going to be increasing from negative infinity, we're assuming it keeps coming from negative infinity, to this value right here, which is, that's 3, so I'm going to say that that's negative 2.4 approximately. Okay, so we're going to increase on that interval. Now the question is, do we include the point in the interval or we don't include the point in the interval? Now there's two different thought processes there, but I believe in this book we include the interval. So that means we're going to go to 2.4 and we're going to close it off like that. Now we're also increasing from this value right here to infinity. So we're going to also have another answer here. So that's one, let's say it's 1.1. So we're going to say 1.1. We're going to include that, and we're going to go to infinity. So it's increasing on both those intervals. So now it's decreasing from 1.1 or negative 2.4. We always go left to right, sorry. So this would be negative 2.4 to 1.1. Okay, and our max here at x equals negative 2.4, and our point that's a maximum, let's say, is negative 2.4 comma, guessing this is 3, so that's 3.5, we'll say 3.4. That's the point that's the maximum, because we got to go over here and look at the y value. It's about 3.4 maybe. And our minimum at x equals 1.1, and our point there would be 1.1 comma negative, it's not quite negative, maybe negative 1, we'll say negative 1. Close enough to that point. Okay, and so that's that. All right, so when you're looking at the graph, you're going to look for moving right, whether it goes up or down. And you can, but when we're looking at a chart, I've got a couple other examples here. We're going to be looking at a chart and seeing if we can determine if we can find a max or a minimum, or whether it's increasing or decreasing. So if we're looking at this chart, this values go up the same amount. So we're looking at these values, and it looks like these values are decreasing. So this is a decreasing function throughout. It doesn't go back up. It goes down 10, it goes down 5, it goes down 3, it goes down 2. So it's always decreasing. We don't have a max or min because it doesn't change. It doesn't go down and then go back up. So if it did that, then we could say there's a max or min in between these values. We wouldn't know exactly where it is. So we can tell if this is a decreasing function, but we can't really tell if this is a maximum here because we don't know what happens before that. All right, and we're looking at this one. This does the opposite. This is an increasing function because it goes up 15, goes up 10, goes up 7, then goes up 3. So it's always increasing. Now, if one of these numbers went back down, like if this went down to 22, then we would have some decreasing happening in between these values. But this is always increasing and always decreasing in this example. All right, we're moving on to the next and last part, which is concavity and inflection points. So we're going to use the same examples on the previous page. Concavity is when the rates of change increases. It's concave up when the rates of change increase, and it's concave down when it decreases. So concavity, concave up means it's going to look something like this, a cup, and concave down means it does this, goes down. Inflection points are where that changes. So on this graph, this looks like it comes down like this. So this is concave down till it gets right about here probably. We're going to say it's about there. Looks like it changes. Maybe it's a little bit further down. It will go right here. So we'll say it changes concavity right there. We have to make an estimate. It's not as clear. So as long as we're close there, it's going to be kind of halfway in between this point and this point. So we're going to say right about there. So that point is called an inflection point. That's when we change, because this is concave down, so this is concave down, and this is concave up right here. And we change concavity right here at this point on the x value. So it's concave up from negative infinity to this x value here, which we're going to say is maybe it's half, or we'll say it's halfway between these. That's 1.5, so we're going to say negative 0.75. We're concave up there. And we're concave down from that point on, so that would be negative 0.75 to infinity, as we're going to be concave up. Now the inflection point is going to happen at negative 0.75, comma, we need to know how high it is. It's right about there. That's 1.5, so 1.4 maybe. You can guess about a tenth off. So that would be my inflection point. That's when it changes from concave down to concave up. Now, if we were using a chart like the charts we had before, we can tell concavity by how it increases or decreases. So here, this is concave. So this is 10 difference here. This is 5. This is 3. This is 2. So that's decreasing. It's going down, but it's the rate of change is decreasing. So that means it's going to look like although it's going up, or I'm sorry, it's going down because it's 90, then 80, then 75. So it's going down. So it's going to look like, if we were graphing it, it would look like this. It would be decreasing the rate of change. So it would be flattening out like this on the graph. All right? Because it's not decreasing. It's decreasing more here. That's 10. It's decreasing less here. So that's going to be concave up on this one. Decreasing at a lower rate. So concave up. on this one. And then this one does the same thing. It goes up, but this is 5, this is 10, this is no, 15, sorry, 15, 10, 7, and 3, right? So it's decreasing. It's also decreasing, but it's going up while it's decreasing, so that means it's doing this, going up and decreasing, so it's not going up as fast. So this is concave down on this one, because we're increasing the values, but we're not going up as fast, so it's flattening out. Okay, so that's how I tell that, by looking at the differences in those, whether rates go up or it goes down. Okay, so that's how what we look for there on that, and that's this section on rates of change and behaviors of graphs.